Okay, in the next section, we will introduce how to add two complex numbers and how to flip a complex number, etc. So, first of all, let's have an introduction with some examples. Okay, so let's do an example. In this example, we have a point A which is corresponding to a complex number z, and then we have another point B which is corresponding to a complex number z, another z, z2. We have a question. The question says draw the sum of two vectors, and two vectors are OA and OB. So first of all, we will draw the two vectors OA and OB, and then we will draw their sum. Okay, we know what is Z1, we know what is Z2. Okay, but we don't know what are A and what are B. But he says that A is the point of this complex number. Okay, so first of all, we know that the first complex number is 4 plus 3 iota, and if I write it as a point A, it must be the first component 4 comma the second component. So we know what is A now. And similarly, Z2 is a complex number called minus 1 plus 2 iota. If I call it as a point B, it must be the first component, which is minus 1, the second component, which is 2. We know what is A and what is B, but we don't know what is OA and what is OB. First of all, I will draw these two things and then I will add them. Okay, let's draw first these 2 points and then I will make OA and OB. So this is the complex plane. So in order to draw 4, 3, 4 means I have to go along x-axis by 4 points. For example, this is 1, this is 2, this is 3, so this is 4. So I will draw 4 with the red one. And the second component is 3. That means along y-axis I have to go up. Because 3 is positive, we will go up by 3 points. Okay, so 1, 2, 3. So this point is the second component. This is the first component, this is the second component. First component is 4 and the second component is 3. We have to make a single point by using both components. So how can I make a single point? Here on each component we draw straight lines. On this component and the other component, I draw both straight lines on both components, and then we will check where is the point where they meet. This is the point where they are meeting. Okay, so we will say this is the point A. Okay, and A is 4, 3. And now we will draw this point B. Point B is minus 1, 2. Minus 1 means, the first component is along x-axis. So I have to draw minus 1 along this horizontal line. But since it is minus, so I will go this way. If it was plus, I should have gone this way, but now I will go this way. So this way, minus 1. Minus 1 is here, right? Just here. Okay. And the second component is 2. That means along this vertical line, I have to go up because it is plus. This is 1 and this is 2. So this let me change the color. Maybe we can use this one. this one and this one. Okay, now I have both components, this one and this one. I have to draw a point. So how can I draw the point? I will draw the straight lines passing through these components first, and I will draw the point where they are meeting. Here they are meeting, so now I will raise them. So this point is point B. Okay, I will call it B of -1 and 2. This is the point B. Okay, now we have drawn both points A and B. Okay, still we don't know what is OA and what is OB vector. Okay, in order to draw OA and OB vectors, what will I do? I will first copy this whole thing here. Okay, and now we can zoom it out a little bit. After zooming out, this is point A, right? So I need OA. In order to draw OA, I will join this point with the origin. This is the origin, so I will join it. Okay, so this is OA. Similarly, this point is B. In order to draw OB, I will join it to the origin, right? So let me join it to the origin. So this is OA and this is OB. Now we have both OA and OB. So you can call it OA and you can call it OB. So we have two vectors OA and OB. Now what I have to do, look at the question again. Draw the sum of two vectors OA and OB. We have both vectors OA and OB. Now we need their sum. How can we add two vectors? So mathematically, if we are asked to add two vectors, we use head to tail rule. Okay, what is head to tail rule? If you have two vectors, for example this vector and the other vector, for example this one, for example you say this vector is u and this vector is v. If you have to add both vectors, what you will do? You will shift one vector and put its tail to the head of the other vector. This way, or put it here, shift it here and put it to the head of the other vector. Whatever you want to do, you can do that. And what will you do? Then you will make a new vector which starts from here and ends here. Okay, so this vector is called u plus v. The new vector, let me mark it by another color. So this new vector is u plus v. So I will call it u plus v. So this is the way how we add two vectors, right? So I will call it head to tail rule. Now I have to add these two vectors. How can I add them? Let's look. What will I do? I will keep this vector and shift it such that its tail is here to the head of the other vector, right? Now I need their sum. So their sum can be found by just making a new vector from here to here. Okay, so this is OA plus OB. If you look at the coordinates of this point. Okay, let's look at another question. We have solved OA and OB. So this is OA and OB. This black vector is OA plus OB, okay? This vector is OB, this vector is OA, and this black vector is their sum OA plus OB, okay? So we have another question. Which complex number does this vector represents? Means the new vector which we have found, that is which is OA plus OB. This is the new vector. So it corresponds to which complex number? Which complex number? I mean A plus B iota. You need this complex number. What is this? So if we look at the diagram, on the diagram we have to check the coordinates of this point. What are the coordinates of this point? If we draw the straight line here, it corresponds to 3, right? If I draw another straight line here, it corresponds to 5, right? Because this is 1, this is 2, this is 3, and here you have 4, and the next one is 5. My scaling is not good, but if you draw it by the proper scaling, you will have 5, okay? So this complex number is 3, 5. Okay, I will write 3, 5. So the answer is 3, 5 by looking at the graph. So by looking at the graph, the complex number represented by this vector OA plus OB from the graph is 3, 5. So 3, 5 means 3 plus 5 iota, right? So I will write is 3 plus 5 iota. Look at the next question. The next question is calculate Z1 plus Z2 using algebraic rules. Previously we had used the graph to add a vector and find its component. Now I will use the algebraic rules to compute Z1 plus Z2, okay? Since Z1 is 4 plus 3 iota and Z2 is minus 1 plus 2 iota, we are asked to find Z1 plus Z2. So Z1 plus Z2 is 4 plus 3 iota, this is Z1, plus minus 1 plus 2 iota, which is Z2. If we add 4 plus 3 iota minus 1 plus 2 iota, this is the number without iota and this is another number without iota. We will add them, 4 minus 1, plus these two numbers are with iota, so I will add these two things. So 3 iota plus 2 iota. 4 minus 1 is 3 and 3 plus 2 is 5. So I got 3 plus 5 iota. If I convert this 3 plus 5 iota into point, it will be 3, 5. But you can check this 3, 5 is the same as what we have got from here using the diagram or the head to tail rule. This means there are two methods to add two vectors. Either you add them by using the diagram here, or you add them by using the algebraic rules. You will get the same answer eventually. Okay? So this is the story about the addition of two vectors. Now we have another story about the flipping of a vector. So let's do another question. Let C be a point represented by this Z3, and we are asked to draw the opposite point of this C, okay? Sorry, we are asked to draw the opposite vector of OC, right? Okay, here is the solution of this question. Since we have the complex number Z, first of all, we will draw C. What is C? Since C is the point represented by the complex number Z3, which is 2 plus iota. So we can call C is equal to, what are the components? The first component is 2, and the second component, what is the coefficient of iota here? It is 1. Okay, so the coefficient of iota, if there is no coefficient, that means it is 1. If this term was not here, that means the coefficient was 0. But since this iota is here, there is no coefficient, so we will say it is 1. So we have found the point C. Now I will find OC. How can I find OC? I will draw the graph. So in this graph, what will I do? I have to represent 2 and 1. 2 along this horizontal line. Since 2 is positive, it will be along right. So I will write 1 and 2. So this is 2. And similarly, this 1 is along y-axis. Since 1 is positive, so I will go up. So I will just write this is 1. Okay. So these are the two components. So, but I need the points. How I will draw the point? I will draw two lines passing through both points, this line and this line. Okay, two straight lines passing through these points. Check where they are intersecting. This is the point where they are intersecting. So this is the corresponding point. So let me draw it clearly. So I will write this is point C. Okay, come back to the question. We have to draw the opposite vector of OC. So first of all, I will draw OC. What is OC? If I have C, I told you previously, you can draw OC by just joining this point to the origin. Okay, so here I have drawn the vector OC. Now I need to draw its opposite vector, right? So what is the opposite vector? Suppose here me and you are standing here. Someone asks you to go there, this side, and asks me to go the opposite side of you. Since you are going this side, so your opposite side is this one. So I will go to this side. Okay, so the opposite vector means the another vector which makes angle of 180 degree. Okay, so I have to find an opposite vector of OC. So if OC is going this way, so opposite must go this way. Okay, how can I draw? What will I do? I will draw the same vector here just in front of it, but I will change its direction. I will reverse its direction. Okay, how can I reverse the direction? So here I have a vector. I will reverse its direction and put it here, right? So now this new vector, which is totally opposite to OC, is called the opposite of OC, right? So I will call it OC but with opposite direction, right? Either, in other words, I can call OC with this direction but with negative, okay? If its arrow will go there, I will call it negative. So there are two representations. This representation is not found in the literature. Usually, if this is OC, then its opposite must be the negative vector, okay? So this is the opposite. Okay, now the next question is, which complex number does this vector represents? This is the vector, it represents some complex number. Okay, so I will check which complex number is represented by this vector. Okay, so if you check what is the complex number does this vector represents? This vector represents this complex number. First it will go here at 2 points, but for the opposite vector I have to go here till 2 points but with negative. So here I will write -2. And once you go from here to here, and then you should go from here to here by 1 point. But once you reach here at the opposite vector side, then you should go down by 1 point, okay? So down 1 point means -1. So this is the number which this vector represents, okay? Okay, so this is the answer. By looking at the graph, we see that the opposite of OC is -2, -1, okay? Another question. The question says, calculate -Z3 using algebraic rules. Okay, so here is the solution. Since Z3 is 2, 1, then -Z3 is just -2, -1. So you can check this -2, -1 is the same as what we have got from here, -2, -1. Okay? So this is the intuition. How can you flip a vector and how can you add two vectors? Okay? See you in the next video.